This call is now being recorded.
Hi everyone. So welcome to Science class Form 1, DLP. Today we go to Chapter 3, Coordination and Response. Okay, so we go through this textbook. Says here, humans and living things move all the time. How do humans and living things regulate the internal environment inside the body? Okay, so today let's study homeostasis in living things. Okay, science bulletin. Our body is the best temperature regulator. Our body temperature generally stays at 37 degrees Celsius so that chemical reactions in the body can function efficiently. Therefore, 37 degrees Celsius is the normal body temperature. I believe this one most of us know already because nowadays when we want to enter shop or mall or Eon, we need to scan our temperature. So if 37 degrees is okay. It is a normal temperature. Okay. Do you know that mammals and birds also have a normal body temperature? Normal body temperature differs according to the types of animals. For example, normal body temperature for a magpie is about 39 degrees Celsius, while normal body temperature for a porcupine is around 31 degrees Celsius. Porcupine, landak. Okay. When we are running, our body produce heat to harbor. That will increase the body temperature, yang akan meningkatkan suhu badan. Thus, the sweat glands, kelenjar peluh, in our body will produce sweat to peluh, to reduce the body temperature. If the body temperature does not drop to its normal range, our body cells cannot function efficiently and it might cause death. So dia cakap kalau badan kita panas, kalau kita tak berpeluh atau kita boleh turunkan suhu badan, kita boleh mati. So the homeostasis is important. Okay. So body temperature exceeding 6 degrees Celsius from the normal temperature will cause death. Therefore, patients with fever should be monitored closely to prevent their body temperature from rising too high. Dia kata suhu badan kita kalau naik lebih sampai 6 degree Celsius. So 6 meaning 37 plus 6, 43. Kalau suhu badan kita 43 degree of Celsius, kita boleh mati. Suhu badan tak boleh naik tinggi sangat. We cannot go too high. Okay. So more than 37, 38 and above, we call as fever. Consider fever. Fever to demam. So we need to monitor our body temperature. Okay. So keywords for today is homeostasis, transpiration, pulse count, regulation, response, and biological action. Go to page 72. So 3.1, homeostasis in living things. So today we will learn about two things first. Communicate about meanings of homeostasis and then explain with example the system involved with homeostasis in humans and animals. Okay. So what is meant by homeostasis? What is homeostasis? Homeostasis refers to the maintenance of the internal environment in the body of an organism, such as temperature, water, pH, and blood pressure to be in a balanced and stable condition. Dia cakap homeostasis tu kawalan dalam badan kita. Control temperature, suhu badan, water, air, kandungan air dalam badan, pH, pH tu acid, alkali, or normal, neutral, and blood pressure tekanan darah, to be in a balanced and stable condition. Okay. So the maintenance of the internal environment in the body of an organism in a balanced and stable condition allows all living process in the body of the organism to work well. If the internal conditions are not balanced, for example, the temperature is too high, demam, okay, the cells of the organism may die. Sel-sel dalam badan sebagainya boleh mati. Okay, so history corner. Homostasis comes from two Greek words, homeo meaning similar and stasis meaning stable. Okay. So homeostasis in humans. Have you ever used an oven? Pernah guna oven? Do you know that a thermostat is used to control the temperature of an oven? If the thermostat detects the temperature of the oven is too high, the heating function in the oven will switch off and the temperature will decrease. Dekat oven ada thermostat can detect the temperature. If too high, the heating function will switch off. Okay. If the thermostat detects the temperature of the oven is too low, the heating function in the oven will switch on to increase the temperature. Okay, this is an example of application. The same goes to our body, which has a mechanism that can regulate body temperature, water content, and others to be in a balanced and stable condition. Now, this is the homeostatic control process. When the internal environment in our body, such as the body temperature increase, the control center at the brain will detect the change. Otak kita, brain, detect change in our body. So, a corrective mechanism, corrective, dia betulkan semula, mekanisme pembetulan, will then take place and the temperature will reduce to its normal range. When the body temperature decreases, a corrective mechanism will take place and the temperature will rise to its normal range in this figure. Okay, so if you look in this figure, this is normal temperature, and then the temperature increase naik, suhu badan jadi lebih naik, meningkat. So control center in our brain asks us to do the corrective mechanism, and then from the corrective mechanism, it will decrease our temperature, akan menurunkan suhu badan with several mechanisms such as sweat, berpeluh. Itu salah satu cara. Okay, so become normal temperature. If the normal temperature decrease, menurun, tiba-tiba jadi sejuk, so control center also will ask to do the corrective mechanism to increase the temperature to become normal again. Okay. So homeostasis is important to humans. Among the most important homeostasis in the human body are the regulation of water and body temperature. So two things are most important for in homeostasis. Regulation of water, kawalan air dalam badan, and body temperature, suhu badan. Okay. Activity 3.1. So we just go through this one to gather information about homeostasis in our body. Okay, I think this one not very important. We proceed to this one, regulation of water content. Okay, systems that are involved in water regulation are the excretory system and endocrine system. I will ask you later, excretory system and endocrine system. Examples of organs involved are kidneys and brain. Kidneys, buah pinggang, kidneys. Okay, this is brain. So, example, we have two diagram here. Okay, on top this one is increase, below here is decrease. Atas air banyak, bawah air kurang. Okay, so let me show you this one. This is normal water level, and then we drink water a lot. So water increase, water level in our body increase. So water content in the body increase when we drink water. Air dalam badan bertambah bila kita minum air. And then our brain detected by the brain. And then corrective mechanism, the brain will stimulate the secretion of a hormone so that the kidneys increase the production of urine. Dia cakap otak akan rangsang, stimulate supaya buah pinggang kita ni akan mengeluarkan lebih banyak air kecil, air kencing. Okay. Then say more urine is produced. Okay. And then after that, water content in the body decrease. Air akan berkurang dalam badan setelah kita buang air, buang air kecil. Okay. This one decrease. Okay. When we exercise, we sweat a lot. We sweat a lot. Okay. Bila kita exercise, berpeluh. keluar air dari badan. Okay. So water content in the body decrease when we sweat. So detected by brain asks to do the corrective mechanism. The brain will stimulate the secretion of a hormone so that the kidney will decrease the production of urine. So buah pinggang dia akan mengurangkan air kencing yang dihasilkan. And then feel thirsty, kita rasa dahaga nak minum air. Okay. After we drink the water content in the body increase, become normal again. Okay. So bila kita berpeluh, kita rasa dahaga nak minum air, kita minum, okay lah. Next, this one body temperature. Previously, this one water, this is water level. Now body temperature. Tadi air dalam badan, sekarang suhu badan. Temperature. Okay, different. So systems that are involved in regulation of body temperatures are excretory system and endocrine system. Same like the water control. Same like water. Okay. Examples of organs involved are skin, brain, and skeletal muscles. Ini lain sikit lah. Skin, kulit, brain, otak. Skeletal muscles, otot, rangka kita. Okay. So, also we have two diagrams. This one. Okay. Normal temperature is 37 degrees Celsius. And then the temperature increase. Suhu naik. Especially during a hot day, waktu keadaan panas. So our temperature, suhu badan kita naik. So what happened? During a hot day, our body temperature will increase. So detected by the brain, what happened? Blood vessels dilate. Blood vessel dilate. Hairs lie flat. Hairs tu ni, bulu, roma, tangan semua ni. Dia akan lie flat. Lie flat tu dia tak naik atas lah, dia bawah dekat tangan. Lie flat. Okay. Increase sweating, berpeluh. Okay. Activity of the skeletal muscles and certain hormone secretion will reduce and eventually decrease the body temperature. Okay. And then less urine. Urine pun kurang lah, air kencing kurang. Okay. After that, body temperature decrease, dia turun, jadi normal balik lah. Okay. What happened when the temperature decrease? Sejuk. We feel cold. Kita rasa sejuk. Okay. So during a cold day, our body temperature will decrease. So badan kita turun. Okay. So this one detected by the brain. What happened? It says here, blood vessels constrict. Hairs stand erect. Hair stands erect tu bulu roma semua tu dia naik ke atas, tegak. Okay. And then decrease sweating, tak berpeluh lah. Okay. Skeletal muscles will contract and relax actively and will cause an individual to shiver. Okay, shiver tu menggeletar. Shiver. To increase the body temperature. We shiver supaya suhu badan tu naik lah. When we shiver, suhu badan akan naik. Okay. At the same time, certain hormones will be secreted to increase body metabolism. Okay. Next, this is about skin layer. Higher surrounding temperature. Ini bila suhu panas, cuaca panas. Okay. Says here, sweat glands produce more sweat to cool the skin when sweat is evaporated. Dia cakap kelenjar peluh akan menghasilkan lebih banyak peluh lah untuk bagi sejuk kulit. Apabila sweat is evaporated, peluh itu kering. Dia kering lah. Okay. Hairs lie flat. Hairs lie flat. Dia dekat tangan kita lah. Okay. To reduce air trap on the skin so that heat can be released easily. Supaya tak panas lah. Okay. So, this is hairs lie flat. Dia dekat dengan skin. Kalau hair stands erect, dia tegak naik atas. Straight. Like this. Okay. So, this is blood vessels dilate. Nampak tu, dia besar. This one blood vessel constrict, kecil. Okay. So this is sweat, air peluh. Air. This is sweat glands, kelenjar peluh. The yellow one, this one. Okay. So it says here, blood vessels dilate to let more blood flow close to the skin to increase heat loss. Okay. And then what happened when in a cold day, lower surrounding temperature. Erect hairs trap a layer of air that act as a heat insulator. Okay, so this is the hair. Example, bulu dekat tangan tu, bulu roma naik atas. Okay, dah banyak lah. So, the hair will trap air. Dia akan perangkapkan udara. Become an insulator to increase heat in our body on our skin. Okay. And then this is so the condition of skin layer during higher and lower surrounding temperature. Okay, we have a video here. So I will show you a video. Okay, let me stop this one first. Okay, I will show you a video. The role of skin thermoregulation. Okay, I hope you can see now. Before that, let me mute my.
Skin not only protects us from the harmful influence of the external environment, it also performs a vital thermoregulatory function. Skin consists of two main layers, external or epidermis, and the dermis located underneath. Under the dermis, there is fat-storing tissue which functions as an insulator preventing heat loss. A similar role is performed by hair, which is an epidermal appendage characteristic of all mammals. In the dermis, there are about 150,000 cold receptors and 16,000 heat receptors which transmit information about the temperature of the environment, particularly about changes in it, to the thermoregulatory centers in the brain. When the temperature of the environment decreases, the blood pressure goes down and arterioles providing blood to the capillaries located in the skin contract. As a result, the blood flow is limited. This prevents heat loss. In the opposite case, the arterioles expand, blood flow increases, and the organism loses heat. High temperature also triggers increased secretion of sweat. Water, which constitutes its main component, is characterized by a high latent heat of evaporation. Water absorbs a considerable amount of heat during evaporation from the skin surface, which results in the cooling of the organism.
Okay. Okay, so let me stop this video now. Okay, continue with the textbook. Okay, so this is experiment 3.1. This is actually a simple experiment. Okay. Okay, experiment 3.1. Do we sweat in a hot or cold condition? Dia tanya kita berpeluh in a hot, panas or cold condition, sejuk. Which one? Okay. So, hypothesis, we sweat in a hot condition. Kita akan berpeluh bila cuaca panas. Okay. Aim to study how the biological actions respond to change in temperature. Variables, manipulated variable, the surrounding temperature. Responding variable, presence of sweat. Fixed variable, time taken. So materials and apparatus, stopwatch, jump. Okay. Procedure, enter the laboratory without switching on the fans for 10 minutes. Hot. Okay. To record whether or not you are sweating. Berpeluh atau tak. Okay. Then switch on the fans for 10 minutes. Record whether or not you are sweating. Results, hot, fan is switched off. Presence of sweat, of course, yes. Cool, fan is switched on. Presence of sweat, less compared to the hot condition. Okay. So question, what will happen to the body when we are in higher surrounding temperature? Of course, we are sweating, berpeluh. Conclusion, is the hypothesis accepted? Yes, the hypothesis accepted. Okay. Experiment 3.2. Does the pulse count increase when executing heavy tasks? Dia cakap nadi kita, nadi. Or we can check here, and our neck also can. Or on our hand here, like this. Pulse, denyut nadi. Okay. So, does the pulse count increase? Dia naik makin cepat atau or not? When we executing heavy tasks, buat kerja berat. Example, exercise lah. Okay. Hypothesis. Pulse count will increase when executing heavy tasks. Aim to study how biological action respond to pulse count. Variables. Manipulated variable, types of activities. Responding variable, pulse count. Fixed variable, time taken. Okay. Materials and apparatus. Stopwatch, a student from each group. Procedure. Choose one student from each group to carry out the activities planned, which are at rest, walking and jogging for 5 minutes. Rest, berehatlah, tak buat apa-apa. Walking, berjalan. Jogging, jogging for 5 minutes. Okay. Then count the pulse of each student for a minute by placing 2 fingers on their wrist and record the reading after each activity. Photograph like 3.3. Okay. Record the result in the table as shown below. So this is our result. Okay. Question. What is shown by the data collected? What other observation can be seen on students after doing heavy tasks? Why is sweat produced when doing heavy tasks? Okay. So, what is shown by the data collected? When the heavier tasks we do, so the pulse count also become more, increase. The pulse count, of course, increase when we do heavier tasks. Okay. What other observation? We also sweat a lot when we do heavier tasks. Okay. Why is sweat produced when doing heavy tasks? Kenapa berpeluh kita buat bila buat kerja berat? Because our temperature, body temperature increase when we are doing heavy tasks. Okay. So conclusion is the hypothesis accepted or rejected. Of course, the hypothesis is accepted. Okay. So today we stop until here. Next week we will go for homeostasis in animals. Okay. So for today, I will stop this recording first.